was a conversation between Gordon McOuat
Yeah.
and Cédric.
Is that what it is? See, that's what I get for putting a conversation with Gordon McOuat in the title of my talk.
It's not what it is. You're going to be.
Well, I invite Gordon to berate me anytime he wants while I speak.
Leader.
How about that?
Okay, so I'll hand it over to you and thank you for being
Okay.
here.
Thank you so much for having me. Do I sit here? Do I stand?
Yep.
That's
Actually, yeah, that's okay. We can see you.
Okay, fantastic. So, hello everyone. I'm Cédric. I'm one of Gordon's former undergraduate students, and I am most importantly a trader and turncoat because I have gone from being one of his history of science and technology students to being a dirty molecular biologist. And so I have come here to throw some punches with Gordon, because I thought that the best way to thank Gordon for all he has done for me is to just
Trash him.
yeah, absolutely. That's the way it usually goes. So Gordon, of course, is the person who, like many others, I think like many others, I was first introduced to the idea of knowledge circulation by Gordon. And I've always been very much fascinated, in particular by the intrinsic tension in the idea that comes with taking something like knowledge and saying that it's going to be fluid and moving and transforming. This especially because now more than before as a scientist, I do like to think that I'm looking for something called the truth. And that's the first signal for Gordon to come and beat the shit out of me. And as such, I wanted to give maybe a personal case study of what knowledge transfer, knowledge circulation might be like, taking it from my personal experience, going from the history of science to science itself in conversation with Gordon, and seeing how both his philosophy has guided, influenced me, and in some ways has been something that I have at times quite simply struggled to understand, and at other times felt like I was chafing against and somehow felt like I had to rebel against. But before anyone jumps to criticize me, I like to make the disclaimer that any misinterpretation, mischaracterization, misreading of anyone here should simply be treated as an actor's category for this presentation, and as such should be taken as genuine regardless of whether or not I got it right or wrong. In any case, my background, I did my bachelor's in history of science and technology here at King's. Have sat in this very room many times. Then I did a quick detour for a master's degree, and then came back to Dalhousie for a PhD in molecular biology. And so I am currently working on that right now. So I'm working in the Archibald lab at Dalhousie University. What we do is comparative genomics, which is to say that we basically study the DNA of diverse organisms to try and reconstruct the history of life and create things like this tree that you can see here on the left, depicting relationships, evolutionary relationships between organisms. I did not start my PhD. My PhD was not my first introduction to the Archibald lab. Actually, the very reason why I was able to get into the Archibald lab in the first place was that when I was a undergraduate student, being a very keen, member of the history of science, I guess, student body, it was Gordon who connected me with Ford Doolittle, and then in turn Ford Doolittle who connected me with John Archibald, so that as an undergraduate student, I might be able to do a stay in the lab as some kind of participant observer, right? Someone who is a visiting historian / philosopher of science who's here to understand the process of how scientific knowledge gets constructed in real time. And this turned into an honors project, which was co-supervised between Gordon and John Archibald, my current PhD supervisor, and then turned into a PhD when I came back. Now, so the kind of one of the fundamental questions that we deal with in the Archibald lab but that I was really first introduced to by Gordon is this question of how is life organized, right? When we depict life, depict the relationships between living beings, what are those relationships? And so, of course, the traditional Western view in general for a long time, pre-Darwin, in fact, has been to represent the relationships between organisms as this kind of great branching tree, which is this kind of hierarchical structure where you have all of these nested sets, and each organism belongs to its own branch, which belongs to its own greater branch, and so on and so forth. Which is a depiction of the system of life that predates Darwin. And then once evolution came into the picture, we came to the conclusion that what we had been depicting before that was in fact evolutionary relationships. Now, of course, being Gordon's student, I was very quickly introduced not only to this, I guess, canonical view of the organization of life, but to some truly fantastical alternatives. And so Gordon very early on introduced me, among many other things, to the thought of the Japanese botanist Bunzo Hayata. And this is a fantastic paper that is here, and I dare any of you to actually find it, because the only reason I have one is that I got a PDF from Gordon via email, and all of the reference information is in Japanese. And the PDF is so poorly scanned that some of the figures are in fact unreadable. So I'm going off with the best that I can have here. But to absolutely butcher and make long story short of a more sophisticated point, in it, Gordon takes Bunzo Hayata's philosophy of taxonomy and tries to open up our mind to a different way of looking at life and a different way of looking at the way in which we organize the relationships between living beings. So what we have here on the left, we have our traditional hierarchical taxonomic tree here depicting the family tree of Charles Darwin. And then on the right here, you have this complex network that is organizing the relationships between these people, not just based on who was descended from who, but on any number of shared traits, whether it be that they share a nose, a beard, gender, history, a preference for pizza, anything you want. The point being that in Bunzo Hayata's view, life is multifaceted in such a way that you can organize and categorize and group things together in really numerous different ways, and not just in that one kind of hierarchical scheme that we are used to working with in biology. And the possibilities, right, that come from looking at this history and considering how we might still do that, I think, was something that I was made aware of by Gordon and very interested in. And so it seemed like the Archibald Lab was a great place to look into this, because in the Archibald Lab, we do some research, in fact, that does upset the idea that there is one big tree. Because what we study is this phenomenon called lateral gene transfer, where essentially very distantly related species end up trading genetic material and DNA. Imagine if a bacterial gene ended up somehow in your germline, and then your children had, when they grew up, a bacterial gene that they could use somehow, right? These kinds of relationship upset the idea that you just have endlessly branching species, because the genetic material can actually move between the distant branches of the tree of life. So from this, you might think that the Archibald Lab is really kind of the best place to do this. But I do distinctly remember, half in jest, Gordon announcing our first meeting with John Archibald, where we're going to sit down as a clash of ideologies between, Gordon's kind of very expensive, rich network view versus the also very interesting, but much more, I guess, materialistic, reductionist, geneticist view that I was going to be contaminated by in the Archibald Lab. And one of the things that Gordon kind of, I think, pushed us to think about was very much the notion of when we talk about relationships between species, when we talk about the idea of hybridity, the idea that an organism might be a chimera of different things. What are the ways in which how we have constructed our understanding of the organisms we're looking at might in fact be the reason why we're talking in terms of hybridity here. So this is a quote from a fairly lengthy email exchange I had with Gordon several years ago, in which he articulated this position. And he writes that he was interested in the ways in which hybridization is, by definition, either one second. Oh, I went back. A hybridization is by definition excluded or minority condition because we excluded its possibility in the kinds of classes we have selected to be germane, which is to say that the kinds of how we choose to define what a species is, what an organism is, we kind of draw barriers between things. And then we show phenomena that break these barriers and go, oh, hybridization. But maybe the very notion of hybridization would be nonsensical if we hadn't drawn these barriers between these classes in the first place. And then, because of course this very much has to do with organisms of study, he added, is this related to model organisms? Perhaps, but I hate models. Fighting words. And so to maybe give you a sense of how that might work, I wanted to take an example for my own current PhD research to try to express the Gordonian perspective, as we might, which is that I study this little single-celled organism called Acanthamoeba castellanii, and this is an organism that gets infected by viruses, and these viruses have DNA in them, and the DNA from these viruses can sometimes, in some rare cases, end up actually into the nucleus, into the genetic material of Acanthamoeba, and stay there over evolutionary timescales, which can produce a phenomenon where you have essentially a kind of hybrid chromosomes, hybrid DNA in Acanthamoeba, where there are entire chunks of Acanthamoeba genomes that I would tell you are actually virus DNA and not Acanthamoeba DNA. But of course, the point I think that Gordon would make is that the very idea that I have a virus / Acanthamoeba DNA hybrid might in fact be a product of the way in which I originally constructed the virus and Acanthamoeba as somehow separate, which they may or may not be. And so it is with this intellectual background here in mind that I jumped into the lab and became a participant observer during my undergrad. And I think I very much took in Gordon's ideas and ran with them. I was very interested because, right, we do genetics, a lot of DNA stuff. I became very interested in the ways in which the movement of DNA in the lab, right, from our benchtop to our computer, between different experiments, might be a process that was somehow constructing the movement of DNA that we were studying also. And you can see these are all slides from PowerPoints that I created in my first year as a participant observer in the lab, looking at what was going on and trying to reconstruct the network of practices that created lateral gene transfer in the lab, the ways in which the scientists kind of produced, the ways in which lateral gene transfer, the transfer of genetic material between organisms, also reflected the transfer of DNA within the lab and the practices of the lab. But even as I did this work, I became increasingly, I'd say, unsatisfied with this kind of network analysis, because more and more I became compelled not with the, I guess, meta-scientific question of how is lateral gene transfer constructed, produced as a kind of artifact of laboratory practice, and became just more interested in just lateral gene transfer itself as a natural phenomenon. I started spending less time asking myself, how have the scientists constructed lateral gene transfer, and more time asking myself, well, is lateral gene transfer real? How often does it happen? Why does it happen? These sorts of questions. And so I became interested in this naturalistic perspective, and being the absolute suck-up that I was, was very intent on using Gordon's own words against me, against him, to try and sell a more naturalistic approach. So this is paraphrased, but from an encounter I distinctly remember. I think this was after a conference where I had heard Gordon talk about an encounter with nature. I think he was talking about statistics, offering up the grounds for a new form of encounter with nature. And I thought to myself, ah, yes, that's the words I will use when I sell my new project, my more natural project. And so, I came back one day or a few days later to Gordon and said, ah, yes, I'd like to experience, show how there's a new encounter with nature in the lab. And of course, Gordon said, well, actually, nature is a really problematic concept, Cédric. Be careful with that one. And I say this, but of course, Gordon was always incredibly supportive of all that I did. And so in the end, the project that I made for my honors presentation ended up being very different from what it had started out as, but I think we were all, both of us, very excited about it still by the end. But still, it is to say that I kind of went from at the beginning very much tracking these networks of practices to delivering a thesis which in a lot of ways was aimed at producing a proper epistemology of lateral gene transfer. There were no graphs of complicated networks and practices that I had spent so many hours producing in the first half of the project. It was very much is it real? Does it happen? What can we know about it? And it was a great time. And this is a kind of shift in focus that has carried on as I continue to work on networks in my PhD work. So what you're seeing up here, those are all networks of actual data that I have produced and analyzed myself. In the process of working on these networks, I have come to the conclusion for myself, at least, that the classes that constitute these networks are, in fact, robustly empirical, materialistic, non-arbitrary, and I mean, in this case, DNA-centric, because I'm focusing, in fact, on DNA, with, of course, 1,000 caveats that I could list to you. But at the end of the day, came out of it, you might say, even pushing back against Gordon's initial question of, are the classes we have created the reason why we can talk about chimeras in the first place? And arrived at the conclusion, at least for myself, that these classes are in fact something out there to some degree, in some way that makes me want to study them. But it was hard to articulate the fault line in the disagreement, I would say, though, because I could never pin Gordon down. It seems like in the breadth of things I had heard him say, I was
This is all true, by the way.
yes. This is all.
Every sentence.
Every single sentence is something that you might, in fact, have heard Gordon say at some point or another. There's also one I couldn't include. My favorite one is actually I'm a positivist on Tuesdays, and if Gordon's a positivist on Tuesdays, then I'm probably a positivist on Monday through Thursday or something like that. But in any case. All of this to say that as I've kind of taken the time for this talk to ponder and reflect about both the things that Gordon has taught me and the things I have refused to be taught, I've started to wonder whether or not my inability to pin him down might be the point.
Exactly.
Yes, and that I was being played the whole time, you might even say, and that even when a few months ago I sat down for lunch and he expounded on me on this very radical view of genetics in which DNA might not even matter. I can't quite remember. Well, does Gordon believe in it? Maybe he does, maybe he doesn't. But the point is that he wants me to encounter it and he wants me to be transformed by it, regardless of where that takes me. And so, like the classic fool who thinks that he can disagree with Hegel and then realizes that he was too part of the inevitable dialectic, I have realized that the one true lesson that I can probably garner from all of this that I can get from Gordon's teaching is the one that was carried forward not in the things that he said, but in the things that he did, which is to say that he brought people together, which is how this conference is also panning out to be. And so we are transformed by our encounters with people. And that, at the end, is the most significant philosophical statement to be made. Which is to say, thank you, Gordon, for bringing us all here. And of course, I would be remiss to not also mention Mary Frappé, who has very much suffered to bring us all here, as well as Megan, who's here, who I understood has also suffered for all of us to be here. So thank you very much, everyone.
For 5 minutes, but I guess, do you want to go first?
We kind of ate up a little bit of
I agree with everything you said.
the question. Anyone wants to ask a question in the minute and a half we have for questions? We kind of ate up the time a little bit.
Okay, we can talk after.
We can talk after. Anyone online who wants to throw their hat in the ring? No one. Okay.
Can I have a comment? I can't help but feel like Ford was up there, but I also feel like Ford is like working in the background here. So
Oh, absolutely.
like in terms of some of the things that you are saying, Gordon is all about. I also could see things that
You didn't
Ford.
Yeah, you didn't include, there was a famous debate that we had here, so shortly after the so-called Ford Little was one of the top molecular biologists in the world, was responding to social constructivism, which I don't have much track with. And he held up, well, you remember, he held up a DNA gel, and he said, for all this construction stuff, this is DNA. It was wonderful because it was soon obsolete, right? And nobody would hold that was DNA moments
We'll
later.
see.
But it was
Yes and
beautiful.
no.
I agreed with him. I said, you're exactly
Yes.
right. That is DNA.
Yes, and so I considered adding that episode in here, cut for time. But I was also going to start with the conflict and then end by saying that in the end, you actually did say that he was right.
That's totally right.
Yes. So. Yeah, thank you.
Well, I'm trying to figure
Thank you
out
so much.
how to connect my presentations.
I was
Well, I'm
gonna.
the thematic of storms, so.
Yes.
Yeah, but storms.
Sweat off the whirling. I'm gonna confess, yes. I saw the meteorology theme and thought, well,
No.
there's no way.
It's fine.
No, it's the dialectic unfolding.
I'm just plugging my computer.
Yes, I think it's great.
It's gonna be a bit hard because we have to log into Zoom.
Yeah.
Do you want to?
So you haven't got
I
the
don't-
PowerPoint?
Huh?
What's happening?
I don't know.
It's
It's not on the thing.
something.
I tested it on my own.
What's the format for the memory stick?
I'm not sure. We could
These are both Macs, so that should work.
do the person online if you want.
Maybe, yeah, maybe we should do that.
That'd be okay? Okay, we could do that.
You have one that was sent to you by email, is that right?
Is it decent by email?
No, because it's so
Okay.
large that it
Okay.
wasn't sending.
Okay, so we might do the online person then first, and then while we figure out the USB stick. Would that be
Would you
okay?
be okay with going next?
Do you care going next?
We're treating a technical problem right now.
Yeah, they're not even moving, so.
It's already short.
Okay, going. Now.
He's moving.
I just sent a message there.
And the feed is working.
Something's happening. Sorry, everyone.
Yeah.
Yes. Yeah.
Then unmute them and allow them to share.
Would you be able to unmute and share your screen?
You hear me?
Yeah, I hear you. Yeah.
I think I'm the third, right?
Yeah, we're just having some difficulties with the second speaker, so would you be okay going second? That'd be right?
Going now.
Going now.
Sorry, I can't, I just hear you clearly. So can you
Oh.
repeat?
Sorry, yeah, would you be okay going now?
Okay, now, so you are talking, be the first one to present myself, or? You
Yeah,
make the
yeah, that'd be
presentation?
okay. And then if you have a presentation, you can share your screen or you can just.
Oh, okay, okay. No problem, yeah.
I tried on here before.
No,
we'll
this-
just go.
you're already.
Okay, let me figure out how to share. Okay. 哎，我得把它打开吧。Wait a minute.
Yeah, no.
Press hard.
Okay, it seems to be there.
Can you see this? Can you see my
Yes,
PowerPoint?
right.
Okay. Okay. Hello, everyone. I'd like to join you in person, but my visa application just failed without any reason. So actually now, can you hear me now?
Yep, yeah, perfect.
Okay. Actually, I'm in Kuala Lumpur, Malaysia, and it is 1 a.m. So I must be looking tired. Yeah, and I have to and I need to catch the flight at around 4 or 5. So I think it's very good for you to let me be the first one. You know. Yeah. Thank you very much. Yeah. Thank you. Yeah, my name is Zhenwu and Zhenwu Qiu. You can just call me Zhenwu, and I teach at Nanjing Normal University, China, and used to. I graduated from Tsinghua University, China, and I used to study in King's College, London, the London one, not the Canada one. Yeah, just for as a visiting PhD student. So now it's my time. At first I'd like to kick off with a story. So in June 1840, the first open war broke out between Britain and China. On 10 September that year, the Golconda, a warship carrying the 37th Madras Native Infantry sailed from Madras, you can see from Madras to China to fight in the open war. However, on its war from Singapore to Macau, the ship was caught in a violent typhoon that killed at least 200 Indian soldiers. According to Henry Piddington, an amateur meteorologist in Calcutta, the shipwreck could have been avoided if the crew had mastered the law of storms in Chinese waters. So my presentation's title is Connecting Caribbean, Calcutta, and China. So it's about the tropical storms. So this is the.
Sorry, I don't think you're, like, we cannot see you sharing your slides.
Oh, you can, okay. Maybe this one.
Okay, there we go.
Yeah,
Yeah.
you need to go to the next slide. There you go. That's good enough. Don't worry about
Okay.
it. Just go through your slides as you're speaking.
Yeah, I will keep it just like this, not the big
Yeah.
one.
No one's trying to
Yeah.
do anything more than this.
You can see the, yeah,
Yeah, great, thank you.
sorry about that. I don't know what happened. Yeah. So this is Henry Piddington. I guess you guys all know about him. And so the questions arise: who was Henry Piddington, and why did he care so much? Why did he care so much about the law of storms? And where did he learn about the tropical storm knowledge? And how was the law of storms produced and circulated across regions within the British Empire? And what was the relationship between the law of storms and the expansion of the British Empire? As we know that British Empire's expansion across the globe was backed by the sea power, and which required a range of marine knowledge, science and knowledge. And tropical cyclones are natural phenomena that occurs in tropical and subtropical waters that often challenge British navigation. Knowledge of tropical cyclones was therefore important in reducing the loss of life and property in British military, exploratory, and commercial activities. Broadly speaking, tropical storm knowledge is part of colonial knowledge. And this variety of research was developed during the 1990s. We can see that there were Brandon Cohen, C.A. Bailey, and Nicola Dirks, and so on. And however, the colonial knowledge they discussed is more related to colonial intelligence and colonial information rather than scientific knowledge. But we also get some works here. In the meantime, in the field of history of science, scholars have become increasingly fascinated by the circulation of knowledge with the emergence of so-called global turn. Nevertheless, this has also led scholars to pay more attention to the co-production of modern science by indigenous people and local knowledge. Yeah, so we've got three brilliant works here, James C. called Copyright Lisa Roberts. We also get a book from Professor McOuat. Yeah, I don't know how to spell your name. I'm sorry. Yeah.
Nobody does.
Yeah.
That's good.
And your book is truly intelligent and inspire me to do this kind of work. The book is titled Circulating Knowledge Between Britain, India, and China. So, nevertheless, as a relatively new field, the global flow of meteorological knowledge is still not fully explored. This is what I'm gonna to talk a little bit here. Since Columbus reached the Americas in the late 15th century, Europeans, including Columbus himself, began to consciously document hurricanes and learn about them from the Caribbean people. The first Englishman to gain such knowledge from the natives was likely Captain Longford, who arrived in 1657 and took on a native servant. It was this servant who introduced Longford to the Caribbean world of maritime knowledge and taught him how to predict hurricanes in advance. According to Longford, it was traditional for both the English and the French on the Caribbean islands to ask the native people around June if there would be a hurricane that year, unlike the other Europeans who viewed such predictions as witchcraft. Longford did not share this belief. Instead, he emphasized that their use of sensory observation, observe the changes of moon, the sky, and the stars, and listen and smell and perceive changes in direction of the winds and so on. Most importantly, Longford also learned how about the rotational nature of hurricanes from the local people, as he consistently referred to them as whirlwinds. This is almost certainly the earliest Western account of the rotational nature of tropical cyclones. And all right, let's reach to the Caribbean Sea. The Caribbean Sea provide a natural laboratory for British understanding of tropical storms. In the early 19th century, a colonial official named William Reed conducted a scientific and systematic study of Caribbean hurricanes. His research had a direct impact on the meteorologist Henry Pittington in Calcutta. So in 1838, Reed published the laws of storms. This book, which encouraged Pittington to focus on cyclone studies in the Bay of Bengal. Pittington was also influenced by Captain Longford, as we mentioned before, and who, in Pittington's view, was the first to suggest the rotational nature of cyclones. This inspired him to introduce the term cyclone in the second edition of his book, the home book, to describe meteorological events that move in spiral. This is his book. Of course, Pittington's research was primarily based in the Bay of Bengal, supported by the expansion of British Empire. The colonial government of India backed his work, and the transnational chambers of commerce within the empire provided him with abundant logbooks. Pittendon's research, logbooks. His research also served the interests of colonial expansion. According to him, the importance of having accurate knowledge of the law of storms for naval and commercial nation like Britain cannot be overstated. Driven by both scientific curiosity and imperial interests, Pittendon was also interested in the typhoons of the southeast coast of China. And this was closely linked to the First Opium War. Before 1842, much of his study on the China Seas relied on second or third-hand sources, resulting in limited and inaccurate information. But it was only after the outbreak of the First Opium War that which led to the dramatic increase of the number of warships and merchant ships traveling to China, and that he gained access to a wealth of data on Chinese typhoons. After the First Opium War, Pittendon and other storm researchers flowed their research flowed into China. In 1842, in 1842, the Qing government signed the Treaty of Nanjing with Britain and was forced to open the ports of Canton, Fuzhou, Xiamen, Ningbo, and also Shanghai to trade. By the end of 1847, an American medical missionary named Daniel Gordon McOuat arrived in Ningbo. 10 years later, he compiled and published a book we called 航海竞争, the navigator's golden needles. This was the first meteorological monograph in Chinese history. In the book, the author emphasized the influence of Western meteorologists such as Pittendon. And as he said, there are Henry Pittendon and Colonial Reed and someone else. Further, in McGowan's statement, Western science was deeply combined with Western religion, which demonstrated the so-called civilization, as he said, in supplying them, the Chinese, with works of scientific character, which shall not only promote their material interests, but also religious truth, shall contribute largely to the intellectual and moral regeneration. So much of the science of meteorology as applies to the subject has been introduced with some general principles of navigation as practiced in the West. The whole being interspersed with remarks of natural and revealed religion. And the most important, he said that the need to ward off evil traditions in the world, actually in China, is even more important than the need to escape the hurricanes at sea. It is true that the Opium Wars opened the doors of China and forced it to join a rapidly globalizing world. However, as to meteorological knowledge, China was by no means a mere passive recipient. Early in the 4th century, the inhabitants of the coastal areas of southern China already regarded the typhoon as a unique atmospheric phenomenon. The character Ju, we call Ju hurricane, also appeared in Nanyue, compiled by Shen Huaiyue in the southern Song dynasties, about 13th century, to refer to tropical cyclones activity. a song compilation quoted the 南越志 太平预览 quoted the 南越志 said 据四方之风也 hurricane with the wind of the four directions implied the rotation nature of the tropical cyclones. So my conclusion is very simple. Yeah, the exploration of knowledge of the natural world can be confined to a particular country or region, nor can it be regarded as a purely scientific activity. It is necessary to review the connections and comparisons between different regions and the logic of power that lies behind the production and the circulation of knowledge. So that's all. Thank you. And I sincerely look forward to your opinions and suggestions. Thank you.
Thank you, gentlemen. We've got, you finished a little shorter than I expected, so we've got at least five minutes for questions.
Okay, yeah.
You other people?
Sure.
Okay.
Hi, it's so nice to meet you. I know we corresponded by email. Can you see me?
Are you Sarah? Okay.
Hello.
The owl's here.
The owl's right
There,
here.
okay, I'm gonna look at the owl.
Nice to meet you, yeah.
So much work on Piddington again and again, and it's really interesting to see this from the perspective of a different region and different, you know, language translations and all that. So I'm curious to know, one of the things I'm curious to know is about how this is connected to storm warning systems that we're developing in the region around the same time, maybe a bit later with Jesuit involvement. Is this, are these different groups of actors who are interested in this kind of storm knowledge from the, you know, the builders of the storm warning systems with their instrumental measurements and all? What is the sort of like sequence, and what are the different communities, interest groups at work there that in those two different projects, the translation work and the infrastructure building?
Okay, yeah, nice to meet you, Sarah. Yeah, yeah, your encouragement and inspired me a lot in doing this kind of meteorological history. Yeah, thank you. And yes, I did some research in my thesis about the storm warning networks or systems. Yeah, if as I recall that in 1842, the Piddington has said that he dreamed of building a kind of a storm warning system, and which could cover both the Bay of Bengal and the China Seas. And he dreamed that one day Britain will take over China and build a storm warning there, and that this kind of knowledge was really storm knowledge was really fundamental to this kind of storm warning systems. And I actually in the last chapter of my thesis discussed how the notions and the exchanges between Calcutta, China, and also Manila, and in terms of storm warning systems, because I found that the Hong Kong and Shanghai, the Hong Kong was really influenced by the model of Calcutta, and Shanghai also has some exchangement and of information between Calcutta and Shanghai, and also Manila. They actually, in some ways, they just competitive with each other, but they also exchange informations. And I found the Jose Arge. Do you know the people who was the director of the Manila Observatory?
Oh, yeah, right.
Yes, yeah. In his report, he actually used some sentences wrote by not Henry Pinkerton, is Henry Blandford. So you can see he was actually influenced by what happens in Calcutta. And also, I found many connections between Shanghai, Hong Kong, Calcutta, and also Manila. Yeah, that this is I'm still working on this paper. Yeah, actually, but what I can say is that just is Robert Bakers had already made some researches on this kind of circulation of information or knowledge, but I think there are also something we can dig into with it, or we can explore the exchange and the circulation of storms, especially not only the storms, storm knowledges, but also the storm warning systems. Yeah, I'm not sure if I make myself clearly. Yeah.
Yeah, no, it's just interesting how different, like different competing imperial groups saw knowledge about storms as somehow useful to their projects in China, whether it's the Jesuits or the British, and then also people have local people at the ports that some of your translation work might uncover.
Yeah, I think you made it right, because many people talked about Henry Pinkerton, but I think nobody just connected him with what happens in China and with the First Opium War. So that's because as a Chinese, I want to involve China in the world history, because in China we usually divide Chinese history and world history separately. Yeah, so I want to connect and combine the or situate China in global history. Yeah.
I'll just jump in there and finish this. Thanks so much, Zhenwu. That was really great.
Thank you. Thank you.
The last speaker is Sarah Carson.
Yeah, it works this time. But I think,
That's
yeah, I took it out.
Oh, this is on?
Yeah, okay.
All right.
One of them just for us.
Easy peasy.
Oh, okay.
Okay, let's share this. Yeah. Oh,
Okay, yeah, sorry, it's a little bit of a opening slide, so. Okay, some more exciting ones.
Are you looking to get back on the Zoom? So you
no, it's for some reason it's open in Cédric's. Just one second. Just one second. There we go, okay.
Okay, so I'm gonna be talking about a different set of storms, I guess. More literally, it's the storms that are associated with rainfall, especially during the Chaturmas, or the 4 months of the monsoon, June to October, that are so critical in South Asia. And let me just start timing myself so and then that kind of, I guess, more social storm and kind of change that was happening in the 20th century due to the massive changes in society, in scientific production, in the rise of nationalism and conversations about imperialism. So it was a time of disarray. This research that I'm going to present to you today is evolves from my dissertation research on the Indian Meteorological Department and its efforts at seasonal prediction, where from that point, I really wanted to know what the other alternative methods of predicting the weather, and especially the monsoon, were on the ground. And so this is my entry into that. Famously, modern meteorology depended on these changes in the 19th century communication networks, technologies that enabled simultaneous measurement and time of data transmission, which we've heard a little bit about. just now, but less studied so far is the history of traditional weather experts who also adapted their techniques, their craft, their institutions in light of social and technological changes in the 20th century. New communication environments spurred a reformulation and different modes of circulation of Sanskrit knowledges in vernacular languages. So the community that I'm focusing on here is a community of jyotiṣastris or jyotishis. They were, we could say, at least one of the traditional, in quotes, groups of experts over the future. And we can translate jyotiṣastra as astral science or astrology. They were, in many ways, the major competitors to the modern scientists when it came to predictive science in certain areas, especially to do with weather, with meteorology, and then with economic things, like figuring out what the prices might be of crops, futures trading, and various kinds of speculation. So many everyday jyotishis would issue specific predictions that might be published in newspapers or in almanacs that were printed usually on a yearly basis. Many of them kind of went boom or bust, but the genre of almanacs is very prolific in South Asia, and also other ephemeral sources like the pojifo, the kind of fruits of the different houses in the sky. So those would be new each year, but a few adapted to some of these changing processes and by publishing full treatises that attempted to lay out an Indic science of rain, and that's what I'm trying to. That's what I'm starting to wrap my mind around here. It's maybe a rain that could be seen as a rough equivalent to modern meteorology, even though the focus was not on measurements of heat and pressure and moisture and those kinds of things that constitute this kind of physics of meteorology in this time period. Their focus was very much on rain and predicting when it would happen and how much. So it's not a perfect equivalency. So far, I found 3 books that have this specific goal that are purely, or at least in their titles, focused on creating a rain science, drawing from Sanskrit knowledge traditions, from sources, textual sources available to these kinds of scholars. All of them focus on rainfall, and these are all in the Hindi language. The 3 titles then are Understanding Rain, Karambini, which is also, he also refers to it as Meghamala, so it's a chain of clouds from which one can tell the health of the kind of future rainfall. And then lastly, Rain Knowledge from Nature, and they are published quite far apart from one another in time, but close to each other in space. So these are the three cities in which these authors resided as they were writing these texts. They're all in the specific region that is colloquially known as Marwar, the territory of the formerly powerful Rajput state in modern day Rajasthan. So we could characterize what happens here as a spread of knowledge from the libraries and gyan bandars or knowledge warehouses, knowledge repositories in Rajasthan through the medium of translation into Hindi, across North and West India, through publications in these books and in kind of discussion and commentary on these new Hindi language books. So instead, all of these authors, instead of discussing rainfall within larger compilations involving other objects of divination, for example, Vastu Shastra, natal charts, marks on bodies, various things that diviners would be interested in, I'm just going to make this point again, they isolated rain, either called Varsha or Rishti, as their subject. And as far as I can tell, this is something fairly novel, this narrowing of subject matter to one subject, or a subject that has resonance in the 20th century in the context of the specialization and professionalization of sciences. The fact that they're all in Rajasthan is interesting. Some of these figures actually characterize Rajasthan as uniquely specialized in rain prediction for at least 2 reasons. One of them had to do with the trading community, where many members were involved in money lending and banking and speculation generally, and so we're very interested in predictive sciences, and that involved, you know, agricultural production. But also because Rajasthan had, well, in certain parts, certainly a desert environment, but a fairly dry environment as well, so that the period of the monsoon was pronounced, and rainfall, as I said, was, you know, rare and critical to survival there. So the arguments that I want to make as I move between these texts in rather quick succession, because I don't have a lot of time, is about how their authors were adapting in different ways to major social and scientific changes, transformations, coming at them from multiple angles. So they were facing challenges from within, this crisis of Sanskrit knowledge systems, especially with the rise of vernacular cultures and the decline of patronage for Sanskrit, and also from, we could also say, without, from modern colonial science. And in the broader context, of course, there were historical processes of nationalism, including the rise of Hinduized forms of nationalism, imperialism, and the professionalization and specialization of sciences. All three of these figures, they critiqued modern science, modern meteorologists, and the institutions and general state of Sanskrit śāstra, or the learning from Sanskrit as well, saying that both were kind of inadequate to the task of predicting rain for the reasons that rain needed predicting in their moment. But it was only a conversation within communities invested in those traditions of Sanskrit knowledge. That was where it would have been a two-way conversation. So these books were embraced among Hindi-speaking communities in non-English spheres, and it wasn't really until the post-colonial period that there was more interaction between meteorologists, professional meteorologists who worked in the meteorological department, and some of these alternative weather experts. So the circulation that was happening was taking place in these vernacular languages. There are major changes happening here, changes in learning structures where earlier experts in these Sanskrit-derived knowledges in jyotiṣa would have learned from a guru and needed the permission and the resources, library resources of the guru to do their own scholarship. There was a decline in the patronage for that kind of system, and that was part of the impetus to start translating things into more spoken, widely understood languages like Hindi, and especially Khari Boli Hindi, which was one of the many dialects that eventually kind of won out in the competition for kind of the standard form. And so, but that was part of keeping these traditions of scholarship live and kind of adequate to the questions of the time. Even as the skills of interpretation of Sanskrit were in decline and opportunities for patronage were vanishing. There's also a change in the kinds of forms that this knowledge might take. We've talked about the shorter and more focused texts. They represent a conversion from this manuscript form, this Granth here, which this one is actually quite short, but these could run hundreds of pages. They're handwritten. I actually cannot read this one because I don't read Sanskrit, and I'm pretty sure that's Sanskrit. Could be Jain Madhuri, but I think it's Sanskrit. So anyway, this is from a Gyan Bandar in Rajasthan, where these are the collections, predictions from the 9 planets, according to the ideas of the agricultural sage Hudbali, and they are from a private collection, so one needs permission in order to access this. And I can't read it because I don't read Sanskrit, so I'm actually kind of mirroring the new readership here, who can access some of the information that would be included in some of these manuscripts that was then translated into Hindi and published on printing presses for a wider audience. So it's the same process that happens everywhere, but this is current, live during the 20th century, happening at the time that my actors are working. Okay, so let me just move to our first text here so we can start to look at how the language, the readership, and the form are all transforming in this period. Mithalal Vyas, in his Vrishti Prabodh, for understanding rain, was the first so far that I have found trying to invent or articulate it in science. He was a Pushkari Brahmin scholar and trader who was living and writing in Bewar. He has written many other books. There are many of them in libraries in India that I can't access, but at least 3 available in North American libraries. So all of his writing had been on jyotiṣa or astral science. He called this text Bharata Vayu Shastra, so the kind of wind or air science of India, translated into English as Indian Meteorology, which is a direct reference and an invitation to people interested in modern science and to English speakers to take a look at this. My colleague, a very good historian at Cambridge University, Charles Singh, has actually examined this text in detail, including the ways it circulated through Hindi journals, reviews and commentaries and reeditions. And its popularity and spread were in large part thanks to the proliferation of these Hindi journals like Saraswati that aim to promote and develop the Hindi language. The reviews of Rishi Prabodh in these journals emphasize its novelty. So that goes some way to supporting my hunch here that this is a pretty new form for this kind of these Sanskrit knowledges to take. What did it look like? Well, first you can see here what the table of contents was. Vyas was inspired to organize his compilations of verses in Sanskrit and Hindi dialects according to an unusual system that had not been attempted before. So rather than using the pre-existing order and chapterization that would be well known, perhaps because it was established by the ancient astrological sage Varaha Mihira, Vyas created an organization around a natural cosmology instead. So he arranged verses by the regions in which the signs or causes of rain would be observed. So first on Earth, boom, in the middle space, we could say atmosphere, but it's a little bit tricky, the translation, antariksha, and in the astral region or divya, and then the mixed nimit are more like things that happen during the certain different months of the year that are some combination of these things, more related to the month than to the place that it is observed. And each of the texts looked something like this. This is a fairly standard form at this point, where you have the name of the chapter, the jyotiṣa month chapter, and then a verse in Sanskrit, or in this case, I think Sanskrit, and then the translation into more commonly spoken Hindi, in which here, for example, the prediction is that if any 5 planets are in the same sign with the sun in jyotiṣa, then in Shravan month, so that later in the monsoon season, there will be a gap in the rain and an umbrella will be broken. I'm not sure if the umbrella is broken because of the frustration that there's no rain or it's windy or something. But in any case, you can tell what's going to happen later in the monsoon season based on what you see, the observations you make in jyotiṣa month. And jyotiṣ were essential because of their knowledge of these astral conjunctions. So unlike with Nimit, or the kinds of signs that you would observe on Earth, which ordinary agriculturalists or farmers could observe themselves, the behavior of animals, for example. Here, they are the jyotishis with their astronomical calculations and their careful observations are needed here. Only they will be able to see this indicator of a bad season or a drought in this period. So this is a unique text for its time. In a sea of annual predictions and almanacs, it was an organized system of Sanskrit and vernacular rain knowledge. I'm probably only going to be able to talk about the second one here because of time. But the next major text I found that has made the same kind of effort to create a rain science, Varsha Kagyan, is by the Pandit Madhusudana Ocha, who was a Maithili Brahmin scholar who served as the chief Pandit of the Maharaja of Jaipur for nearly 4 decades. He was in the more traditional milieu for one of these kinds of Sanskrit scholars. So he was in the royal court of Jaipur. So an increasingly rare position, sponsored by a princely state. And he was distinguished by his expertise in Vedic texts. He worked in the wake of popularization of Vedic knowledge by the Arya Samaj and figures like Vivekananda and Swami Dayananda and so forth, who created this Back to the Vedas movement, this idea that the Vedas were the kind of core text of Hinduism, which they were arguing was a singular religion. That's been pushed apart quite a bit, but the Arya Samajists were not big fans of jyotiṣa though. But one thing that they did was, or Dayananda at least did, was that he saw opportunities to go back to the Vedas and instead of focusing on the ritual content to think about the cosmology of it. And Madhusudan actually followed his lead in that effort and developed his own idiosyncratic esoteric cosmology. He would not have been happy about the fact that his work was distributed. Unlike the Arya Samaj, he was committed to sadhana dharma, which meant that he believed that the Vedas should not be heard by Shudras and women and impure people. So he did not intend this to go out to a wide readership, but it was his family and his later followers who undertook the work to bring this. They undertook a project of posthumous publication and reputation building of Ocha. It started actually by his son, who was the one who brought this to publication a few years after his death only. So one thing that's different from Vyasa's work is that he was reaching toward a unified physical theory rather than a collection of different signs that could help one predict the season. In his introduction, he gave some interpretation of the Vedic cosmology of why rain falls, but the theories he expounded upon here were not primarily Vedic. He explained how the yajna, or the sacrifice, caused the mixing of Soma and Agni in the sky, and by feeding Soma to Agni, by performing these sacrifices, one releases particles into the atmosphere, and this all creates precipitation. But he didn't really go into that much. Apparently he had intentions to write a different part that was on the Vedic theory of rain, but here he seemed to be drawing mostly from the Samhitas like Varahamihira, who I previously mentioned, these ancient scholars who wrote sometime in the first millennium CE. And his physical explanation that he focused on was more about what's called the garb, or the vrishti garb, the rain pregnancy, the embryo of rain, which is nurtured, as he said, over the course of 8 months. Others have said 195 days for various reasons. But so he was focused on understanding how rain developed as a pregnancy. And then, through the course of 8 months, was the pregnancy might be successful or it might be aborted. And then the outcome was the birth, or in the Chaturmas, or the monsoon season. He actually criticized a lot of the almanac predictions, this what he called the calendrical rain prediction method, because it was divorced, or at least insofar it was divorced from physical understandings and explanations for the mechanism of monsoon rainfall. Table of contents here shows how he was looking at this theory of pregnancy. So in the first part, he was describing the rain embryo, or the pregnancy of the clouds, discussing things like labor, prasav, abortion, garbha pagat, and injury, or upkrama. The second part, I haven't fully translated all of this yet, so this is how I understand it right now. But the second part was about the signs that the embryo would be successful, or would be healthy, or breaking up based on signs from the Indian months, kind of occurrences during the Indian months. The third, signs of the condition of the embryo that he considered nimittas, so the sun's rays. This seems to be things that happen in the Antariksha sphere, meteors or falling stars, the diffusion of clouds. And then finally, the study of omens, which seems to be things that predict imminent rain, so signs on Earth, or sometimes signs, astral signs like eclipses and things of that nature. All within this one larger physical explanation of how seasonal rain gestates in clouds over the course of those 8 months, and then rains during the 4 months of the monsoon. His audience were, as I said, were more serious scholars and the king of Jaipur. He was interested not so much in the best predictive methods, but instead the deeper knowledge of rain as a substance and a force in the universe, and creating a science on that basis. So for that reason, he split up his attempt in a very, he organized his attempt in a very different way and drew on different sources. And I'm going to skip this one here because I've run out of time. But suffice it to say that Nata is a Jain and a Rajasthani kind of literature patriot. So there was a different flavor there, which was more about Rajasthani knowledge systems and more kind of local names and words and sources for weather knowledge. So then just to sum up, jyotiṣ were battling at least 3 threats: the disparagement of their expertise by colonial modernists, interested in modern science, the drying up of patronage networks, and increasingly incursions into their field by non-traditional practitioners of jyotiṣ. So that was expanding into new spaces, including universities. Michael Dodson has done work on this, including periodicals and also including these kind of new books that were print books. Much of this was in vernacular languages, and I've just treated here things that were in Hindi, but there would be other kinds of discourses in other languages, I'm sure. The only other thing I know a little bit more about is Bangla, but here in Hindi, there was more focus on these kinds of concerted scientific projects to create a rain science. This was a product of the situation of being colonized, but also of an ongoing adaptability of long-standing knowledge traditions and the richness of the work in the vernaculars at this moment. While Sanskrit learning and production may have been in decline, the resources were moving into new spaces and being transformed to meet new needs in the 20th century. They were reinterpreted in a new context. So I will leave it there.
I'm technically out of time, but if you wanted one question.
There's nobody in this room after this, so we can go a little longer.
Go for it.
Just a suggestion.
Yeah.
There's a wonderful book that was here in French, but is now translated into English. Yeah. And it's called Words of Destiny.
Yeah.
And she is, as far as I know, the only person who's done in-depth research into the movement of this non-response. And her work also tells you in the early 20th century, prediction, Shagunadhyaya, once Banaras University was founded, and one has been a mother in kind of nationalist imaginary was that we bring everything that's happened in European science and its greatness and merge it with Sanskrit science. Right? So I think you would learn a lot if you read.
Yeah, I've read parts of her work. Haven't gotten the chance to meet her yet, but it does seem like Banaras University, because of its patronage of, or its department, it's created a modern scientific.
Yeah, it has a jyotiṣ department.
Yeah. So that is an important site where a lot of this is going on, and I have looked at their curriculums, and they do have some of this. They do have.
Catherine has published the curricula for the last 10 or 15 years.
Yeah, no, so I've seen that they do have some of the rain knowledge, rain prediction. That's one of the, it's kind of like, it's not a huge part of the curriculum, but it is one of those sections.
But she did, because she's an anthropologist, that's what she did field work. So she did say, it's not just what you see in the text, there are actually lots of conversations in the classroom around it.
Yeah, super interesting. I really hope I get the chance to meet her.
She's lovely. You can email her. She'd immediately.
Yeah, I asked her to be on a panel once and it didn't work out because she was in the field. Yeah, so I guess that one of my hunches, and I am curious to hear what you think about this, is that jyotiṣ. So there's been a lot of work about the kind of individuation of Sanskrit sciences, kind of in the model of Western sciences in some ways, like race science, sexology, and right? Yeah. Okay, so a lot of those are sciences of society, which have to do with past, present, and future for sure, but they're very important to everyone. There's been some work about the sciences of the past as well as being crucial to the nationalist project and the kind of nationalist understanding of science. My hunch is that this is where the politics of the future are kind of surrounding, not just, there are visions of the future and kind of techno-scientific visions of the future, but the actual ability to predict the